Now imagine the possibilities. Could our very existence be at the mercy of these cosmic giants? Join me on this journey through the mysteries of space as we uncover the truth behind supernovae and their impact on our world. From the distant reaches of the universe to the secrets hidden within our own galaxy, we'll explore the awe-inspiring forces that shape our cosmic neighborhood. But I don't want to embark on this adventure alone. I want to hear your thoughts and questions along the way. What do you think about the potential dangers lurking in space? Drop a comment below and let's start a conversation. And if you're as intrigued as I am by the wonders of the cosmos, don't forget to smash that like button and hit subscribe for more mind-blowing content. Together, let's unlock the mysteries of the universe and journey to the furthest reaches of space. Are you ready? Let's dive in. Come on, let's plunge into the deep unknown of space. Together, we'll unravel the secrets of supernovae, a cosmic spectacle that could either paint our world with destruction or adorn our night sky with mesmerizing beauty. First things first, let's talk about some good news. Supernovae aren't as common in our galaxy as you might think. While astronomers observe plenty of them in distant galaxies every year, our Milky Way experiences only a handful, about 2 to 3, every 100 years. So, while the odds of witnessing one tomorrow are slim, they're not impossible. Interestingly, scientists believe Earth has encountered a supernova blast at least once during its 4.5 billion years of existence. Imagine this: you're by your window, and suddenly a dazzling light bursts into the sky. It's as radiant as the full moon, perhaps even brighter, visible even in daylight. But hold on tight. This unexpected star is showering us with gamma radiation and X-rays, stripping our protective ozone layer and leaving us exposed to the sun's deadly rays. Meanwhile, a colossal wave of stellar debris races towards Earth at mind-boggling speeds like a cosmic inferno. That's the spectacle of a supernova, or at least one possible portrayal if it were to occur nearby. But how probable is this scenario? How close must a supernova be to threaten life here? What would our experience be like, and which nearby stars might ignite this cosmic fireworks show? Researchers have uncovered evidence hinting at a supernova explosion that occurred roughly 2.5 million years ago. They detected elevated levels of iron-60 and manganese-53 in a specific layer of Earth's past. Fortunately, this explosion was distant and didn't pose a threat to us, but the future might hold different dangers. Some scientists speculate that a chunk of supernova debris wiped out woolly mammoths approximately 13,000 years ago. Magnetic spirals and radioactive potassium-40 found at the impact site suggest remnants of a supernova. Even earlier, mammoth tusks dating back 34,000 years displayed tiny craters caused by fast-moving grains of slightly radioactive iron. Recall, these grains traveled at speeds akin to those of supernova explosions. It must have been quite a surprise for those mammoths. A keen observer might notice a crucial point here. Despite experiencing 3 supernova explosions in the last 20 million years, life on Earth has persisted since its beginnings about 3.7 billion years ago. So while supernovae are indeed powerful, they may not be as devastating as initially feared. However, the level of danger depends on how close we are to the explosion. Imagine being 1,000 kilometers away from a nuclear blast. It's not a major concern. But if that explosion happened right on your coffee table, it's a different story. Similarly, when it comes to supernovae, the universe seems to have vast distances between them, like large coffee tables. Understanding the sheer magnitude of these explosions requires delving into the forces at play, which means gaining a better grasp of how supernovae occur. Essentially, there are 2 primary routes that stars can take to reach this explosive grand finale. In both cases, however, it's crucial that the star in question is of the right kind. Let's start with the first path leading to a Type 1a supernova. Typically, this involves a white dwarf star in a binary system gradually accumulating matter from its companion star until it hits a critical mass. While this process isn't entirely clear, it's believed that a white dwarf, a dense star resembling a giant superdiamond core, is usually delicately balanced between two mighty forces: electron degeneracy pressure and gravity. In simpler terms, atoms prefer not to be squished too tightly. Their electrons have specific distances they like to maintain from the atom's nucleus and resist being compressed beyond that point. However, gravity is an immensely potent force, especially within a compact mass like a white dwarf, where a section as small as a sugar cube possesses the mass of roughly a car. In a binary system where the white dwarf is absorbing increasing amounts of matter from its partner star, gravity eventually triumphs over electron degeneracy pressure, causing the entire structure to collapse suddenly. Carbon fusion ignites, sparking a rapid chain reaction within the star. In mere moments, the star's core transforms, giving birth to heavier elements while unleashing an immense surge of energy. Just how much energy? Picture this: around 1/4 decillion joules, a staggering number with 45 zeros following it. If you claim you knew this figure beforehand, well, you might be stretching the truth a bit. This colossal release of energy occurs within seconds, causing the star to expel its entire contents outward in a spectacular display. Hurtling at 6% of the speed of light, the ejected matter radiates a flood of gamma radiation across the galaxy. The intensity of this event outshines our Sun by a whopping 5 billion times, casting its brilliance for several weeks until the ejected material disperses far enough for the energy levels to gradually diminish. In wrapping up our cosmic adventure, we've delved into the awe-inspiring world of supernovae, uncovering their types and the incredible forces fueling their explosive brilliance. But hold on tight, because our cosmic journey is far from over. If you've been captivated by what you've seen, make sure to give that like button a gentle tap and share this video with your fellow cosmic enthusiasts. And if you haven't already, consider hitting that subscribe button to stay updated on all our space science explorations. We're eager to hear your thoughts and suggestions, so don't hesitate to drop a comment below. Tell us what topics you'd like us to dive into next. Together, let's continue unlocking the mysteries of the universe. Thanks for joining us on this cosmic voyage, and remember, keep your eyes fixed on the stars.